Good morning, everyone. My name is Jacqueline Warber, and I am an engineering student here at the University of Wisconsin-Madison. And today, my team and I, with Alex, Matt, and Jessica, who are also engineers here at the University of Wisconsin-Madison, are going to be taking you a little further back for our ethics in engineering presentation to talk to you about the Great Molasses Flood of 1919. You are living on the north side of Boston, and it's just a normal, typical day. And you wake up, you step outside, it's sunny, it's beautiful out. It's not cold, but not warm, kind of how it is here, around 40 degrees. And then suddenly you hear this really loud creaking metal scraping noise, and you're very confused. So you look around looking for where it's coming from. And you turn to your left, and you see a 15-foot wave of dark, sticky brown liquid, which later you'll find is molasses, that is hurtling at you at 35 miles per hour. What do you do? This disaster will be later known as the Great Molasses Flood of 1919. And as a civil engineer at Southern Illinois University, Mark Rosso once said, taken from an article written by History.com, when you actually hear what happened, first you laugh about it, but then you realize it was actually the furthest thing from being funny or humorous. And today I'm going to give you a little bit of the introduction to what happened during this flood. After I cover the introduction, like the what, when, where, the general information about the Great Molasses Flood and what exactly happened, as I said earlier, this is an ethics and engineering presentation. So we'll be getting into the ethical questions behind what happened, the risks, the what if, long-term results, and the conclusion as well as next steps. And although this did happen a long time ago, as I said, 1919, it's still very important to consider the ethical question behind what exactly happened. So before I get into the actual day of the molasses flood, which was January 15th, 1919 at 12:40 p.m., we have to go back into why all of that molasses was there in the first place. So it was just nearing the end of World War I, but ammunition production was still very high. And molasses, which is a byproduct of sugar, was used to make that ammunition as well as liquor. So, as you can see in the picture to the lower left of me, behind the house there was a large 50-foot container, and that is what held all of the molasses. So molasses was continuously being shipped in and held in that container. Employees did complain that the stability and structure of the container itself was not enough to hold that much molasses. But besides it being recocked a couple times, nothing was done. Citizens also complained that there was spillage onto the streets at times, so while it wasn't a flood, the container was still showing signs that it could very well just fall apart. So, back to the day, January 15th, 2.3 million gallons spilled out into the streets of Boston, 15-foot wave, 35 miles per hour, picked up anything in its path. Steel train cars, people, animals. So it wasn't just the fact that a huge, heavy wave was coming at you, but as well as something you couldn't even see could strike you in the head and kill you. There ended up being 21 dead and 150 injured. And it wasn't even the fact that the wave itself was deadly, it was more or less after. As I said earlier, it was 40 degrees, so still cold enough for the molasses to harden, and once it did, it trapped a lot of people in very bad places that ended up leading to their death. So on top of the initial wave itself, there was suffocation and entrapment. And this container was owned by the USIA, which stands for United States Industrial Alcohol Company. And they claimed sabotage by Italian anarchist terrorists, which at the time was a very relevant thing. And after years of court and years of battle and debating, and the families pretty much claiming that it was the USIA's fault, the judge determined that the USIA was at fault, and they paid $628,000 to the families, which equals to about $8 million today.
My name is Jessica, and I'm studying environmental engineering. And today I will be going over the ethical questions posed and the lessons learned from the Great Molasses Flood of 1919. So first, who was responsible? The USIA was ultimately deemed responsible in court cases and the settlement due to their lack of proper care and their negligence. When first constructing the tank, they failed to run proper tests, such as filling the tank up with water to see if there was any spilling, leaking, or cracking. When also met with complaints from their employees, they recocked it, as Jacqueline stated before, but they also repainted it a rusty brown red color to mask the color of the molasses. There's also not a whole lot of safety precautions taken during construction. The wall tanks were too thin, and especially at the top, rivet joints were the cracks formed and most likely spilled out into the streets. They far surpassed their allowable loads, which resulted in the flooding. And back then, science wasn't as advanced as we have nowadays. So structural engineers didn't know that they mixed too little manganese with the steel, and that resulted in a brittleness and resulted in the collapse during the cold. So, what were some of the lessons learned? Obviously, cutting corners is bad and it usually costs you more in the long run if failures like these occur. Routine checkups and maintenance are very, very important. So you test the durability of your structures, and besides just recalking it and repainting it. Also, public safety regulations are necessary, and I believe this did enforce some more stricter codes in later engineering projects, as we learned from this. And chemistry plays also a very important role in engineering and understanding the chemical makeup of your materials and deciding what materials you want to use.
So, what were the long term effects of an accident like this one? It actually led to the standardization of many construction practices, and it created an approval process before construction can begin. The Boston Building Department began requiring that all calculations from engineers and architects be filed with their plans, and stamped drawings must be signed, a practice that became standard across the entire country. This accident influenced the adoption of engineering certification laws in all states, something that may not have been created so soon had it not been for this disaster. Apart from molasses kind of being sticky, hard, and tasting pretty badly, it really doesn't have a lot of chemical properties that are super dangerous to human health or property, apart from when you have a flood sized volume of it. But storage tanks hold a lot more things other than molasses or simple chemicals. And had it really not been for this disaster and the creation of these standards, it's very possible we could have had similar chemical flood of a far more dangerous chemical than molasses. And ultimately, this molasses disaster kind of paving the way for better standardization of practices, very similar to the Coconut Grove nightclub fire did for fire code laws. Cutting corners is not only a health hazard when things break or go wrong, but are often associated with financial burden on those responsible. And in the case of companies, public relations often takes a hit as well on situations like these. And companies will really only cut corners when deadlines are looming and budgets are short, but it's these oversights that really hurt the most. And in this case, I need to build a storage tank quickly and cheaply, using poor rivet joints and irregular maintenance checks are those examples of corners cut in order to save money. This accident was fortunate for being just molasses when it could have been like gasoline or natural gas, but ultimately the risks ignored are the risks inherited. But it is also important to ask why something like this could have happened in the first place.
This case is unique among engineering failures for how black and white it is. For the most part, I think we can all agree that first covering up the flaws of a tank and then blaming its eventual failure on Italian anarchists is not the right thing to do. That said, there is one element of this catastrophe that I think is a little bit more nuanced from an ethical perspective. For the workers who were paid to repaint and recaulk the tank while it was failing, what would have been the right thing for them to do? In order to judge the ethics of a real-world event, we must first select an ethical framework through which it may be viewed. Contractarianism is a relevant framework that describes the relationship between the individual and the society they live in. In a nutshell, contractarianism states that the individual signs a contract with the broader society, agreeing on their ends to follow certain rules and guidelines. In exchange, the society grants certain rights, privileges, and protections to the individual. One of the major elements of most social contracts is warning others about potential for harm when it is noticed. This means that if an employee repairing or repainting the tank suddenly realizes the tank's potential for failure, even if it is not his job to report to the company and/or government, it is his contractual obligation to do so. That said, it is entirely possible that the employee, even while doing their job, never realizes that the tank could fail at any moment. In this case, the worker would be absolved of any responsibility according to contractarianism. This goes to show that applying ethics to the real world is not always as simple as it may seem. A different ethical framework may reach a more conclusive judgment. Utilitarianism is another ethical framework that specializes in the relationship that an individual has with the larger society. Grossly simplified, the idea behind utilitarianism is that the individual must act to create the most pleasure for the most people. Utilitarianism is also a highly outcome-centric philosophy. This means there is no absolvement from the social contract because there is no social contract. All that matters is the outcome. If the worker's actions, whatever they may be, succeed in maximizing pleasure, then the worker has done the ethically right thing. If else, then the worker has done the wrong thing, regardless of the reason. This means that those who caulked and painted the tank were also in part responsible for this tank's failure and flooding, regardless if they understood what was going on. In fact, utilitarianism would say that the workers were responsible for both understanding that there is a problem and for notifying the others, as these are both necessary steps for maximizing pleasure for all. To recap, we reviewed what the Great Molasses Flood was, how the flood happened and who was responsible, what lessons were learned, what the long-term results were in light of the flood, the risks of ignoring the results and lessons, and a minor discussion about ethics and responsibility. This wraps up our presentation on the Great Molasses Flood. We thank you all for listening, and we hope you learned something new about this incident. If you have any questions, you are now free to type them out in the chat. Thank you.